Goldsmith, and this is my report for Physics 2212, Lab 2, Lines of Charge. The introduction to the purpose and preview of the result of this lab. The purpose was to create a computational model to simulate the interaction from Lab 1 between two pieces of charged tape, this time using a more accurate line charge as opposed to representing the tape as point charges, although in this case we just used a line of point charges as opposed to a full integral to create a line charge. And the result was that we found a slightly different value of 1.057 times 10 to the negative 8th coulombs for the charge of one of the pieces of tape. So some of the models and fundamental principles we have are Coulomb's law, that the electric force is equal to the Coulomb's constant times the charge of the two particles at hand over the distance between those particles squared. Newton's second law, leading to the force due to gravity, F equals mg, and the charge of a line charge, which uses the superposition principle, the fact that a group of point charges will superimpose additively their electric fields on top of one another and to create a larger electric field. And we're taking, in theory, the limit as dq approaches 0, or as close as we can, of where dq is the width of each of those point charges along the line charge. Some assumptions were that the charge tapes each held about the same amount of charge, and that the charge had been evenly distributed along the surface of the tapes, both of which are not extremely likely. And then we also had to assume that the electric force only acted in the y direction, which would mean that the tapes were perfectly perpendicular to the force of gravity, and also that is extremely unlikely, which probably caused error in the physical model. There were other causes of error, such as whenever my hands touch the tape, etc. In the normal one, in the original experiment, system was the two pieces of tape, and the surroundings were the earth, the air, and my hands. The initial conditions were that the tape had a neutral charge, and then we created that charge by ripping two pieces of tape apart. The tapes were about 0.005 meters apart in the first experiment as well, which is important here, as we see in the results. The length of each piece of tape was 0.2 meters, the mass was about 0.0002 kilograms, and as I said, they were 0.005 meters apart, which gave us a gravitational and electric force in theory of 0.00196 newtons, and an electric charge on the tape, or of the tape, of 2.33 times 10 to the negative 9th coulombs. Again, a very important number. I'll go through the code quickly here. So here we're initializing values. We have k, Coulomb's constant, acceleration due to gravity, the mass of one of the pieces of tape. Then we have the q, the charge on a piece of tape estimated from the first lab, and then what I found through trial and error, basically, to be the more accurate, hopefully, charge from this simulation. Here, this is defining an electric field by using Coulomb's law. The Q times K times R hat over the magnitude of R squared creates the electric field. And then here we have a line charge being created with n equally spaced charges along that line. In my case, I used 1,000 charges within each of the line charges, as that was about as high as GlowScript would allow me to go without crashing. And then we're just initializing the positions of each of the two line charges in question. Here we're scaling our vectors and initializing the forces. Then here we are using Coulomb's law to here multiply the electric field by the charge of each of those point charges to find the electric field at every single one of those point charges, and then we add those up to find the total electric force on the charged tape and the total charge on each tape, which I found to be 1.057 times 10 to the negative 8th, as stated previously, as opposed to the 2.33 times 10 to the negative 9th I found in the previous lab. And that's the difference between the two of them, is that the charges would only be acting in one direction if we were modeling as point charges as in the last experiment, resulting in the estimate of charge being slightly different and probably less accurate. Why is that? The point charge model is less accurate because if the models, it models the tapes as if they were, as the name states, only a point, while the line charge model is not entirely accurate due to the fact that the glow script isn't taking the actual limit as DQ approaches 0 in this case, and the fact that the charge is not always evenly distributed along the tape. It is probably more accurate than the point charge model due to the fact that it estimates based on charges being distributed along the entire length of the tape as opposed to all of it being concentrated in just one spot. Thank you.